Curious title: What Northrop Grumman's autonomous systems teach you about building self-driving ideas from almost nothing. Imagine a small unmanned aircraft quietly mapping a damaged road after a storm, or an autonomous boat checking buoys while a weary crew sleeps. A machine moves without a human at the controls, making safe choices, reporting back useful data, and freeing people to do higher-value work. That capability, autonomy, feels advanced, even distant. Yet the thinking behind it contains repeatable patterns you can borrow to invent practical, dependable products and services, even if you start with almost nothing. This story uses Northrop Grumman's work in autonomous systems as a living example to show how to ideate reliably useful offerings for local markets, side hustles, and small enterprises. Part 1: Introduction, Context, and the first 3 idea principles. Purpose and audience. This training story is written for entrepreneurs who are just getting started, people who are unemployed or underemployed and want to create extra income, individuals on social security seeking practical, low-risk ways to ideate products or services. We are not asking you to design aircraft control laws or build classified systems. Instead, we borrow the design patterns behind resilient autonomous systems: clear mission definitions, robust sensing and feedback, graceful degradation, modular design, and disciplined testing. Translate them into actionable lessons for small, low-capital ventures. What Northrop Grumman's autonomous systems are. Northrop Grumman develops and integrates autonomous systems across air, sea, and land domains. These systems range from unmanned aerial vehicles to undersea vehicles and ground robots, plus the software, sensors, communications, and control algorithms that let machines act with some degree of independence. Key capabilities include mission planning, sensor fusion, combining inputs from multiple sensors to form a reliable picture of the environment, safe navigation, communication with human operators, and the ability to handle failures without catastrophic outcomes. Why autonomous systems matter for idea generation. Autonomy is not just a technical novelty. It is a set of design answers to common problems: unreliable human labor in dangerous environments, repetitive low-value tasks that steal attention, and the need to gather consistent, timely data. Borrowing the autonomy mindset yields powerful lessons for small ventures. Define a clear mission. Autonomy succeeds when the objective is specific and measurable. Build layered sensing and feedback. Redundancy and cross-checks make systems trustworthy. Design for graceful failure. Systems that fail safely preserve trust and can be recovered. Modularize complexity. Separate perception, planning, and action, so improvements are incremental. Emphasize testing under real conditions. Lab success is not the same as field success. How Northrop Grumman compares with other players. To sharpen the lessons, compare Northrop Grumman's approach to several archetypes and companies. Versus hobbyist drone makers. Hobbyist drones prioritize accessibility, low cost, and fast feature cycles. They are great for rapid prototyping and local services. Northrop Grumman's systems focus on mission assurance, hardened communications, and regulated environments. Lesson: prototype fast and cheap, but when reliability matters, invest in disciplined testing and predictable fallback behaviors. Versus technology platform companies. Some large tech companies emphasize machine learning models and software platforms, expecting the cloud and scale to solve many problems. Northrop Grumman integrates tailored hardware, rigorous safety engineering, and domain expertise for mission contexts. Lesson: Software alone is rarely sufficient for high-stakes outcomes. You must align hardware, process, and human oversight. Versus regulated industrial suppliers, firms that serve oil and gas or maritime markets designed for long service life and maintainability. Northrop Grumman blends that industrial rigor with system autonomy. Lesson: for customers who depend on uptime and safety, designed for maintainability and predictable life cycles, not just novelty. The 8 idea generation principles inspired by autonomous systems. Across 3 parts, we will develop 8 principles you can apply to ideation at human scale. In this first part, we explore the first 3 principles in depth. The full set is: Principle 1. Define a narrow mission and optimize every choice to keep it. Principle 2. Build layered sensing and cross-checks. Trust comes from redundancy and verification. Principle 3. Design for graceful degradation. Plan how things fail and how you recover. Principle 4. Modularize perception, planning, and action, so improvements are incremental. Principle 5. Close the feedback loop. Measure what matters and iterate quickly. Principle 6. Harden communications and expectations. Make latency and limits explicit. Principle 7. Make human oversight simple and effective. Use humans where judgment matters. Principle 8. Validate in real conditions and document the results. Testing is policy. In this part we will cover Principle 1, Principle 2, and Principle 3. Each principle includes an explanation, common mistakes companies make, practical lessons, low-cost application steps, a short comparison vignette, and a micro-exercise you can do today. Principle 1. Define a narrow mission and optimize every choice to keep it. Explanation. Autonomous systems work best when given a clear, constrained mission. An unmanned surface vehicle tasked with inspect this pipeline span for corrosion and report anomalies under calm sea states within a defined zone is far easier to design and verify than a machine told to handle any maritime task anywhere. Clarity reduces edge cases, limits sensing requirements, and makes safety measures practical. For small ventures, the equivalent is choosing a narrow job customers care about and designing every process, pricing, training, tools to keep that promise reliably. Why this matters for small founders and makers. When resources are limited, scope is your most powerful multiplier. A narrow mission concentrates development and customer experience so you can be dependable. Customers often prefer a dependable, narrow service to a broad, unreliable one. 3 common mistakes companies make. Mistake 1. Trying to be everything to everyone. Founders sometimes expand scope too early, thinking more features attract more customers. Instead, scope creep dilutes reliability and increases training and operating complexity. Mistake 2. Using fuzzy service descriptions, phrases like fast delivery or returns handled, leave customers guessing. A vague promise prevents you from building predictable operations. Mistake 3. Defining mission by technology instead of customer job. Describing a product by its tech, we use autonomous sensors rather than by the customer problem. We keep roofs inspected monthly so hotels avoid leaks. It makes it hard for customers to see value. Lessons learned and practical steps. Lesson 1. Write one concise mission sentence. State the problem, the boundary, and the measurable outcome. Example. We inspect the hotel roofs in our neighborhood weekly and alert managers to leaks with photos and location within 1 business day. Lesson 2. Let the mission drive design choices. Every tool, price tier, training checklist, and marketing line should trace back to the mission sentence. If it does not help keep the promise, defer or drop it. Lesson 3. Geography, time, or conditions. To reduce edge cases, limit early offers to a neighborhood, a specific operating window, or defined environmental conditions. This reduces failure modes and makes testing tractable. Low-cost application steps. Step 1. Pick a single customer job you can perform repeatedly. Step 2. Define operating constraints you will not exceed. Times, areas, conditions. Step 3. Run small pilot with 3 to 5 customers and document the outcomes and exceptions. Short comparison, vignette. An agricultural sensor startup promised automated farm monitoring. After failing in varied climates, they shifted to soil moisture alerts for small vegetable farms within a single watershed. This narrower mission made hardware selection and testing practical and improved adoption. Micro exercise you can do today. Write one sentence that defines the narrow mission for an idea you care about. Share it with one potential customer and ask, "Would you pay for that?" Use the answer to refine the sentence. Principle 2. Build layered sensing and cross-checks. Trust comes from redundancy and verification. Explanation autonomous platforms combine multiple sensors, cameras, radar, LiDAR, inertial sensors, GPS, and environmental sensors to build a reliable view of the world. Each sensor has strengths and blind spots. Combining them reduces false alarms and missed events. Cross-checks and sanity filters, for example, comparing GPS position with inertial motion and visual features, make the system robust to single sensor failures. For a small venture, the lesson is to avoid single-channel decisions. Use different ways to confirm critical facts before promising outcomes or billing customers. Why this matters for human-scale applications. Mistakes happen when decisions rest on a single input. A misread in voice, a missed phone call, or a lone customer report can cause preventable failure. Simple redundancy. 2 independent confirmations cuts errors dramatically at low cost. 3 common mistakes companies make. Mistake 1. Relying on a single unreliable input. Using only one data source, a single supplier, a single sensor, or a single human check, creates blind spots that lead to mistakes. Mistake 2. Building complex sensor suites when simple redundancy would suffice. Some teams add expensive complexity when a cheap second check, a human call, a photo, or a timestamp would prevent most errors. Mistake 3. Ignoring disagreement policies. When 2 inputs disagree, teams sometimes have no policy and either guess or delay. Lack of a clear rule increases inconsistency and customer frustration. Lessons learned and practical steps. Lesson 1. Identify the mission as critical facts and verify them twice. For a delivery service, confirm address by both the customer form and a quick call. For a local inspection, require a photo and a time-stamped GPS ping. Lesson 2. Use different modalities for redundancy. Combine automated checks with human verification. For example, a machine records a temperature outlier and a technician confirms with a handheld thermometer before an alarm is raised. Lesson 3. Define clear policies for disagreement and escalate predictably. Write a short script. If inputs disagree, hold action and notify the customer with an estimated resolution time, or use a simple majority rule if 3 checks exist. Low-cost application steps. Step 1. List the 3 facts that must be right for your promise to hold. Step 2. For each fact, add 1 low-cost, independent verification method. Step 3. Write a 2-line disagreement policy and test it with a scenario. Short comparison vignette. A small inspection service initially trusted automatic image recognition to flag roof damage. After a false positive caused unnecessary repairs, they added a human review on flagged items before sending invoices. False positives dropped, and customer trust recovered. Micro exercise you can do today. Take a core promise you make to customers and list 2 independent ways to verify the critical condition required to keep the promise. Principle free. Design for graceful degradation. Plan how things fail and how you recover. Explanation. In high-reliability autonomous systems, engineers accept that components will fail. The key is graceful degradation. When a sensor, actuator, or commons link fails, the system reduces capability in predictable ways, alerts operators, and takes safe actions. For example, a drone may return to base or loiter and communicate its degraded state rather than attempt risky maneuvers. Small ventures can adopt the same mindset. Design reduced what safe service modes and simple recovery paths so that a failure does not cause catastrophic or irreparable customer harm. Why graceful degradation matters for small operators. Customers forgive limited failure when it is handled predictably and with dignity. What they cannot forgive is sudden loss without communication or remediation. A plan for degraded performance preserves trust and often converts near failures into loyalty. 3 common mistakes companies make. Mistake 1. Assuming all or nothing operation. Many services treat failures as binary, either full service or canceled orders. This leads to lost opportunities. Offer reduced or delayed service transparently. Mistake 2. Not communicating degradation promptly. Delays or partial service that are not communicated cause anger and churn. Silence compounds the impact of failure. Mistake 3. Lacking a simple, testable recovery procedure. Without rehearsed recovery steps. Who calls the customer? Who arranges a workaround? Teams improvise and make inconsistent choices that harm reputation. Lessons learned and practical steps. Lesson 1. Define at least 2 degraded modes for your service and what they mean to customers. For example, delayed delivery within 4 hours with a 10% discount, or inspection completed without a thermal scan. Lesson 2. Mate or script the customer message for degradations. A short, clear message explaining the reduced service and next steps calms customers and sets expectations. Lesson 3. Practice the recovery routine periodically. A practice 10-minute script and fallback plan beats ad hoc crisis management. Rehearse with your team or a partner. Low-cost application steps. Step 1. List the top 3 failures that would affect your promise. Step 2. For each failure, define a degradations mode, a customer message template, and 1 recovery action. Step 3. Run a tabletop drill with a friend acting as the upset customer and refine the script. Short comparison vignette. An automated local pickup service experienced a scheduling system outage. They moved to a graceful degradation mode. Drivers used a paper manifest, and each affected customer received an SMS explaining a short delay and a discount offer. A company recovered without lost customers because the plan was simple and communicated promptly. Micro exercise you can do today. Write 1 degraded mode for your core promise and draft the 2-line message you will send customers if that mode activates. Part 1 Quick Toolkit and 3 micro exercises you can run now. Toolkit summary. Mission sentence template. We will do this job within geographic time condition constraint and deliverable outcome. Text verification template. List critical fact, primary input, secondary input, disagreement rule. graceful degradation card, failure, degraded mode, customer message, recovery action. 3 micro exercises. Exercise 1. Draft your one-sentence mission and share it with one prospective customer. Record feedback. Exercise 2. For your mission, list 3 critical facts and add independent verification for each. Exercise 3. Identify 2 likely failures and write the customer message you will use for each degraded mode. Short vignette. Small shoreline monitoring pilot that adopted autonomous patterns. A local environmental group wanted low-cost weekly checks of beach erosion. They started with a narrow mission: weekly photos of 3 specific transects posted by Sunday noon. They verified location with GPS on 2 phones, required both photos and a short text note, and planned a degraded mode. If weather prevented drone flights, volunteers would take manual photos and the group would publish a status update. The clarity and the fallback plan made local hotels and regulators comfortable paying a small subscription for consistent data. Conclusion of Part 1. Autonomous systems are often portrayed as futuristic and remote, but the core design choices, narrow missions, layered verification, and graceful degradation, practical tools for anyone building a dependable service. For entrepreneurs with limited capital, these principles reduce wasted effort and increase trust. In Part 2, we will cover modular architectures, feedback loops, and communications, how to build incrementally and learn fast. Part 3 will finish with human oversight, hardened expectations, and field validation practices that let you scale responsibly. If you found this useful, subscribe to my YouTube channel for Part 2 and Part 3, where I will share templates, scripts, and a workbook you can use to pilot an idea in a single week. Hit subscribe so you do not miss the downloads and short videos that make these steps practical and repeatable. Part 2. Modular architecture, feedback loops, and hardened communications. Imagine an autonomous boat that maps a harbor. One day its camera blurs from salt spray. Another day its GPS drifts near tall cranes. Instead of collapsing, the system hands off tasks to a simpler sensor, flags the operator, and continues mapping safe zones. That seamless handoff, modular systems that learn, measure, and communicate clearly, is what separates fragile prototypes from dependable services. In this part, we unpack the next 3 Northrop Grumman inspired lessons you can apply to small ventures. Split complexity into modules, close tight feedback loops, and harden communications and expectations so customers and partners know exactly what to expect. Who this part is for. This section continues the training for entrepreneurs refining an idea, people who are unemployed or underemployed seeking steady micro-income, individuals on social support who want low-risk, practical ways to build reliable services. We assume you practice the first 3 principles from Part 1. Define a narrow mission, add layered verification, and design graceful degradation. Now we translate system architecture, measurement discipline, and resilient communications into everyday actions you can implement without big budgets. Overview of the 3 principles covered here. Principle 4. Modularize perception, planning, and action so improvements are incremental and safe. Principle 5. Close the feedback loop. Measure outcomes, learn fast, and prioritize fixes that matter. Principle 6. Harden communications and expectations. Make latency, limits, and responsibilities explicit. Each principle below includes an explanation, 3 common mistakes companies make, practical lessons, low-cost steps you can take now, a short comparison vignette, and a micro-exercise. Principle 4. Modularize perception, planning, and action. so improvements are incremental and safe. Explanation: autonomous systems separates at decision-making, planning, and execution, action. This modularity reduces coupling. You can improve the camera pipeline without rewriting control code or swap a planner without replacing sensors. For a small venture, modular design means breaking your service into manageable, testable pieces: intake, verification, execution, and follow-up. So you can train people or automate parts one at a time and recover quickly from errors. Why this matters for human-scale projects: when everything is tightly coupled, a small change causes big regressions. Modularity lets you iterate where it matters, onboard helpers fast, and scale by replacing modules with better versions over time, rather than rebuilding whole systems. 3 common mistakes companies make. Mistake 1. Treating the whole service as a monolith. Teams build single scripts or workflows where every change risks breaking the entire offering. That leads to slow updates and fear of change. Mistake 2. Documenting processes poorly or not at all. When modules are only understood by one person, scaling and handoffs fail. New helpers waste time learning idiosyncratic tricks. Mistake 3. Forgetting module interfaces. Even clear modules fail if handoffs lack read fields. Who provides what, in what format, and by when? Lessons learned and practical steps. Lesson 1. Define clear modules and their contracts. Name each module and list its inputs, outputs, and one quality checkpoint. For example, intake requires order details, outputs a confirmed slot, and checks that address fields validate. Lesson 2. Keep modules small and testable. If a module cannot be taught in a short briefing and validated with a quick checklist, split it into simpler pieces. Lesson 3. Design stable interfaces between modules. Agree on minimal handoff data, 5 fields or fewer if possible, so errors do not proliferate across the chain. How to apply Principle 4 cheaply. Step 1. Map your service into 4 modules: intake, verify, execute, and confirm. Step 2. For each module, create a one-page checklist with inputs, outputs, and a single quality test. Step 3. Run a role swap. Have someone else perform one module using only the checklist. If they succeed, the module is robust. Short comparison vignette. A startup that managed deliveries as a single shared Google Sheet suffered frequent errors when one column format changed. After modularizing, separate forms for orders, separate sheets for routing, and a delivery confirmation module. Mistakes dropped and new careers learned their role in minutes. Micro exercise you can do today. Pick one repeatable task in your service and write a one-page checklist that someone else could use after a 10-minute briefing. Principle 5. Close the feedback loop, measure outcomes, learn fast, and prioritize fixes that matter. Explanation. Autonomous platforms use sensors and logs to measure performance continuously and trigger rapid updates. For small ventures, the equivalent is disciplined outcome tracking. Capture a few indicators tied directly to your promise, review them frequently, and make one change at a time to learn causally. Feedback must be timely, actionable, and tightly linked to operations. Why this matters for small teams and not chase every metric. Focused feedback turns scarce effort into measurable improvement and prevents firefighting blindfolded. 3 common mistakes companies make. Mistake 1. Measuring busy work instead of impact. Tracking tasks completed or app users without connecting to customer outcomes wastes effort. Mistake 2. Changing many variables at once. When teams tweet multiple things, they cannot know which change caused improvement or harm. Mistake 3. Failing to include frontline notes with numbers. Metrics without context lead to wrong fixes. A spike in delays could be a weather effect or a supplier change. Lessons learned and practical steps. Lesson 1. Pick a tiny dashboard of 3 leading indicators. Choose metrics that predict your promise. Examples: percent on promise, lead time median, and exception rate per 100 tasks. Lesson 2. Run short experiments with one change at a time. Change one process element for a week, measure the effect, and revert or adopt. Lesson 3. Pair each metric with a one-line frontline note. Require operators or helpers to record a brief cause when exceptions occur. Numbers plus notes reveal root causes quickly. How to apply Principle 5 on a shoestring. Step 1. Choose 3 metrics that map to your core promise and start recording them daily. Step 2. Hold a short weekly review and select one small experiment to run the following week. Step 3. After 1 week, compare metrics and frontline notes to decide whether to keep the change. Short comparison vignette. The drone inspection service. Track number of flights per week, but not percent of usable images. After switching to percent usable images as a key metric and experimenting with camera angles, the usable rate rose and customers stopped asking for repeat visits. Micro exercise you can do today. Write down 3 metrics that predict your promise and record them for the next 7 days. Add a one-line note each time an exception occurs. Principle 6. Harden communications and expectations. Make latency, limits, and responsibilities explicit. Explanation. Autonomous systems explicitly model communications constraints, latency, packet loss, bandwidth, and expose limits to human supervisors. Customers and operators who understand limits make better decisions. 4 small ventures, clearly communicating what you will and will not do, typical timelines, and whom to contact for exceptions reduces friction and builds trust. Why this matters for customer relationships. Surprises erode trust faster than modest shortcomings communicated early. Clear, honest expectations reduce support load and create predictable escalation paths. 3 common mistakes companies make. Mistake 1. Promising instant results when systems have latency. Claiming immediate responses when humans or third parties are involved creates impossible expectations. Mistake 2. Hiding limitations until failure. Only revealing constraints after a missed promise frustrates customers and damages reputation. Mistake 3. Lacking a clear escalation path. When problems occur, customers want to know who will fix them and how long it will take. Without an explicit path, calls spin in circles. Lessons learned and practical steps. Lesson 1. State service latency and limits upfront in simple language. Tell customers expected response times and common exclusions. We aim to respond within 2 business hours. Heavy rain may delay inspections. Lesson 2. Use templated messages for exception and escalation communication. Short, consistent templates reduce confusion and speed resolution. Lesson 3. Assign clear ownership for each part of the process. List who owns intake, verification, execution, and support, even if those roles are the same person. Customers like names and faces. How to apply Principle 6 with minimal text. Step 1. Draft a short FAQ that states expected timelines, conditions causing delays, and exact contact methods. Step 2. Create 2 message templates. One for routine updates and one for exceptions that include next steps and estimated time to resolution. Step 3. Put owner names and phone or chat contact on every client receipt or confirmation. Short comparison vignette. A mapping startup suffered angry clients because inspections took longer during midday heat. After adding a simple line to its booking page about preferred early morning windows in hot seasons and a template explaining delays, client satisfaction rose and calls decreased. Micro exercise you can do today. Write one paragraph FAQ stating your expected timeline, to common causes of delay, and the escalation contact. Share it with a current customer and ask for feedback. Putting principles 4 through 6 together. An integrated example. Imagine a small automated inspection service that promises weekly roof photos with basic damage flags. Apply the 3 principles. Modularize. Intake form, autonomous capture module, human verification module, and final report module, each with a one-page checklist and clear handoffs. Feedback loop. Track % of usable photos, average time between capture and report, and rate of false positives. Run weekly experiments changing flight altitude or camera settings. Harden communications. Publish a simple booking FAQ that notes weather limits, response timelines, and who to call for urgent issues. Use templated exception messages when storms cause delays. This integrated approach makes the service reliable and scalable, and it keeps customers informed and confident. Practical exercises you can do this week. Exercise 1. Modular checklist drill. Choose one module and write a one-page checklist. Have a friend use it after a short briefing and record the result. Exercise 2. 7-day metric sprint. Pick 3 metrics and record them daily for a week, adding one-line frontline notes for exceptions. Run one small experiment in week 2. Exercise 3. FAQ and templates. Draft your service FAQ and 2 templates. Routine update and exception notice, and send them to 5 customers for feedback. Common questions and short answers. Question. I am a team of 1. How do I modularize? Answer. Modularity still helps. Split tasks mentally and document them so you can outsource or hand off single modules to helpers without breaking the whole flow. Question. Which 3 metrics should I pick? Answer. Choose metrics that predict your promise. For delivery promises, pick on promise rate, median lead time, and exception rate. For inspection, pick usable, output rate, time to report, and false positive rate. Question. How detailed should communication templates be? Answer. Keep them short and customer-focused. What happened? What you will do next, and an estimated time to resolution. Comparison roundup. Autonomous systems thinking versus other mindsets. Archetype 1. The monolithic MVP, a monolithic prototype, risks big regressions when you change a single feature. Modularity and small experiments reduce that risk. Archetype 2. The metrics-heavy fantasy. Collecting data is good. Collecting everything without a plan wastes time. Focused metrics with frontline notes are more actionable. Archetype 3. The optimistic promises model. Promising instantaneous perfection without clear limits creates fragile trust. Explicit expectations and graceful degradation preserve credibility. Short vignette. A coastal survey team that scaled reliably. A volunteer survey team formalized its work into modules, tracked usable image rates, and added a clear booking FAQ about weather limits. With those changes, it handled more clients, trained volunteers faster, and generated small paid contracts with local authorities. Wrap-up of Part 2. Modular architecture, rapid feedback, and hardened communications let small teams iterate safely, learn quickly, and keep customers informed when reality interferes. These techniques make autonomy patterns practical at human scale. You do not need exotic sensors or huge budgets to get the right disciplines in place. Preview of Part 3. In the final part, we will cover human oversight, hardened expectations in contracts and service-level commitments, and field validation practices that let you scale responsibly. We will also provide ready-to-use templates, module checklists, a 3-metric tracker, communication templates, and a short pilot plan. If this part helped you, subscribe to my YouTube channel for Part 3 and the downloadable templates. Hit subscribe so you do not miss the workbook and short videos that make launching a dependable service practical and repeatable. Part 3. Human Oversight, Service-Level Promises, and Field Validation. Picture an autonomous patrol boat that flags an anomaly, and the human operator reviews the evidence, confirms the alert, and directs targeted response, all within a calm, predictable workflow. That handoff between machine and human, backed by clear service promises and real-world testing, is what turns promising prototypes into dependable offerings customers will pay for. In this final part, we show how to design human oversight, write honest service-level commitments, validate in the field, and package everything into a pilot you can run quickly with limited resources. Who this part is for, this section continues the training for entrepreneurs refining practical services, people who are unemployed or underemployed and want steady micro-income, individuals on social support seeking low-risk ways to pilot and scale ideas. You have practiced narrow missions, layered verification, graceful degradation, modular design, focused feedback, and hardened communications. Now we finish with 2 funnel principles and a compact, actionable workbook that helps you pilot an idea and convert reliability into repeatable revenue. Overview of the final principles in this part. Principle 7. Make human oversight simple, meaningful, and low friction. Principle 8. Validate in real conditions and make incremental commitments you can keep. Principle 7. Make human oversight simple, meaningful, and low friction. Explanation: autonomous systems amplify human capacity, but they rarely replace judgment completely. The right design places humans where their judgment matters most and makes their interactions efficient and low stress. For small ventures, human oversight may be a part-time operator, a paid consultant, or an on-call partner. The goal is to design oversight so it is easy to perform, clearly valuable, and tightly integrated with automated checks. Why this matters for small providers. When humans are needed for safety, quality, or escalation, oversight should not be a burden. If the human role is confusing or time-consuming, responsiveness drops and stress rises. Simple, effective oversight preserves trust and keeps operations resilient. Common mistakes companies make. Mistake 1. Making human review tedious and time-consuming. If a human must watch long videos or read dense reports, they will delay responses or miss issues. Mistake 2. Leaving humans with unclear authority or ambiguous actions. When a reviewer is unsure what decision to make, they hesitate or make inconsistent choices. Mistake 3. Designing oversight as a post-mortem rather than a real-time support. If humans only see problems after customers complain, the value of oversight is lost. Lessons learned and practical steps. Lesson 1. Design concise human tasks with clear outcomes. Turn long tasks into short decision points. Approve, escalate, or mark resolved. Each action should have an associated script or checklist. Lesson 2. Give humans effective tools, not raw data. Summarize sensor feeds into short, prioritized items with context, one-sentence findings, thumbnails, and recommended next steps. Lesson 3. Define clear authorities and response timelines. State who can approve refunds, who schedules on-site checks, and how long reviews should take. Keep timelines reasonable and communicate them to customers. How to apply Principle 7 cheaply. Step 1. Identify the smallest oversight tasks that catch most errors. For example, a 5-second glance at a flagged image with a one-line confirmed any option. Step 2. Create short scripts for each decision path. Write two-line scripts for the most common outcomes so reviewers act consistently. Step 3. Set up a lightweight notification system. Use simple messages, SMS, messaging app, or email to route items to reviewers and track response times. Short comparison vignette. A coastal monitoring pilot used a human-in-the-loop approach where volunteers reviewed only flagged images and confirmed findings in under a minute. Volunteers enjoyed the short tasks and accuracy improved dramatically compared with fully automated flags. Micro exercise you can do today. Take a current quality check in your work. Reduce it to a single decision with a 2-line script and time yourself doing it. If you can complete it in under a minute, you have a good candidate for human oversight. Principle 8. Validate in real conditions and make incremental commitments you can keep. Explanation. Field validation reveals the gap between laboratory expectations and everyday reality. Autonomous systems that perform well in controlled tests often encounter unexpected environmental conditions, user behaviors, or integration issues in the field. Validating in realistic settings with a small set of honest customers exposes these issues early. Pair validation with incremental, limited commitments so you can learn without risking credibility. Why this matters for early-stage ideas. Real-world pilots teach faster and cheaper than large launches. Small, transparent commitments let you gather evidence, refine operations, and build a credible record of performance that supports higher pricing and broader uptake later. Common mistakes companies make. Mistake 1. Piloting in sterile conditions that never match production. A test in perfect weather tells little about routine operations in rain, crowds, or variable connectivity. Mistake 2. Overpromising based on pilot results from atypical environment. If your pilot clients are unusually patient or forgiving, scaling to typical customers will reveal problems. Mistake 3. Making grand guarantees too early. Bold guarantees without field-proven processes lead to failures and reputational damage. Lessons learned and practical steps. Lesson 1. Pilot with a narrow promise, limited geography, and explicit constraints. Use the mission sentence and constraints you defined earlier. State them clearly to pilot customers. Lesson 2. Recruit honest pilot customers and set expectations. Invite customers who will give candid feedback and agree to limited terms during the pilot. Lesson 3. Record evidence and refine operations iteratively. Collect the metrics you chose, frontline notes, and customer feedback. Use weekly reviews to adjust processes and expand only when performance is consistently meeting targets. How to apply Principle 8 on a shoestring. Step 1. Run a short, constrained pilot with 2 to 5 customers for a fixed period. Keep the geography small and the operating conditions clear. Step 2. Publish a simple pilot report at the end of the trial. Summarize results, exceptions, and planned fixes. Share it with pilot customers and prospects. Step 3. Use pilot evidence to present realistic offers and guarantees. Show data on on-promise rates and response times. Use that evidence to justify a modest guarantee or premium tier. Short comparison vignette of road conditions, sensing startup piloted in a small town that had unusually stable weather and low traffic. After expanding to a neighboring region with heavy rain, their rates of unusable data rose. They then redesigned sensors and redefined acceptable weather windows, and subsequent pilots matched initial expectations because constraints were realistic. Micro exercise you can do today. Plan a 1-month pilot with one customer. Define the mission sentence, 3 metrics you will collect, the constraints you will accept, and 1 low-cost redundancy you will keep on hand. Tell the customer what you will deliver and how you will communicate exceptions. Final toolkit, templates and practical plays you can use immediately. Toolkit items you can create and use today. Mission sentenced, template. We will do this job within geography, time conditions and deliver result. 2-check verification card, list a critical fact, primary input, secondary input, and disagreement rule. Degraded mode card, failure, reduced offer, customer message, recovery step. 1-minute oversight script, 3 possible actions and 2-line scripts for each. Pilot plan sheet, customer, mission, metrics, constraints, redundancy, pilot period, evidence reporting. Practical plays to turn validation into credibility. Start small and honest. Pilot in a constrained area and publish a candid report. Convert pilot customers into reference stories. 1 short quote and 1 measurable result are more persuasive than long brochures. Offer a modest guarantee after you have pilot evidence. A narrow, credible promise builds confidence without risking collapse. Workbook a simple 4-step pilot plan. Step 1. Define the mission and constraints in 1 sentence. Step 2. Choose 3 metrics and 1 redundancy. Step 3. Recruit up to 5 pilot customers and agree on the limited terms. Step 4. Run the pilot for a short period, record daily metrics and frontline notes, and produce a 2-page pilot report. Practical exercises you can do this week. Exercise 1. 1-minute oversight drill. Pick a common automated alert and design a decision script that takes 1 minute or less for human review. Time the process and refine. Exercise 2. 7-day pilot snapshot. Run a tiny pilot for 7 days with a single customer. Collect your 3 metrics and 1 frontline note per exception. Share a 1-page interim report. Exercise 3. Pilot evidence card. Write a 2-line customer quote and a 1-line metric that summarizes pilot performance. Use this in outreach or a listing. Common questions and short answers. Question: I cannot find pilot customers willing to be honest. What now? Answer: offer a small discount or trial in exchange for candid feedback. Emphasize that their input shapes the service they will rely on later. Question: how long should a pilot run? Answer: long enough to see representative variability, typically a few weeks to a month, but short enough to keep learning cycles fast. Question: what if pilot results are poor? Answer: treat pilots as experiments. Document failures, fix root causes, and run a second pilot. Transparency with pilot customers helps preserve relationships. Comparison roundup: autonomous thinking versus other launch mindsets. Archetype 1. Height first launches. Promising wide capability without field evidence leads to customer disappointment. Pilots and honest constraints build durable trust. Archetype 2. Internal-only testing. Closed tests hide real user friction. Shared pilots produce useful feedback and early advocates. Archetype 3. Grand guarantees without proof. Guarantees should be grounded in measured performance. Small, credible promises scale better than bold, unverifiable claims. Final vignette, from pilot to paid service. A small company piloted an autonomous inventory scanner in a set of neighborhood shops, promising a weekly shelf count with alerts for out-of-stock items. They defined a narrow mission, verified counts with a second human check for flagged discrepancies, and planned a degraded mode of manual counts during heavy rain. After a 4-week pilot with 3 shops, they published a simple report showing improvement in shelf accuracy and a modest decrease in stockouts. One shop paid for a monthly subscription, citing reduced panic orders and easier restocking. The company used the pilot evidence and that first reference to sign to more customers. Closing thoughts. From autonomous systems to autonomous advantages. Northrop Grumman's autonomous systems are sophisticated, but the transferable lessons are not technical arcana. They are disciplined design patterns, narrow missions, layered verification, graceful degradation, modular architecture, focused feedback, explicit communication, efficient human oversight, and realistic field validation. For entrepreneurs with limited capital or uncertain employment, these patterns offer a practical path. Design small, test honestly, protect trust, and grow with evidence. If you want downloadable templates, mission sentence sheets, 2-check cards, degraded mode cards, oversight scripts, and a pilot plan, subscribe to my YouTube channel. I post short videos and downloadable workbooks that help you run a pilot in a week and turn dependable operations into paying customers. Hit subscribe and join the next session where we walk through a live pilot step by step. OpenAI GPT-5.